This is part of the revision series. And today we are looking at engineering mathematics. And engineering mathematics, what I am noticing is there are a fixed number of questions. There are roughly about 12 marks. Okay. But getting 9 plus these days, specifically in the biomedical paper, is getting really, really hard. Notice, so most of the students, BM students or those who take the BM, these, let's say, BM students are giving BM examination. These students have an aversion towards. Most of the students somehow tried the NEET exam, then they missed the cutoff or they missed the rank or something like that. They couldn't get a seat, and then they chose something related to healthcare, which is biomedical. Unfortunately, biomedical engineering needs a lot of mathematics, and that comes as a big surprise once you join the. So they have a sort of aversion towards math. And then in students, technically, there are many programs, say in mechanical engineering at IIT Bombay, things like that, where you can give the gate paper in anything, and your qualifying degree could be in mechanical. The gate paper can be any discipline. That means you can give a relatively easy biomedical paper and still get a seat, mechanical seat. Okay. This has been the case. There are some possibilities like that. So technically, students from other branches, because they find the BM paper, they are also started giving this. Now we also have the other category. Doctors who feel getting an engineering exposure can really help them tackle real world healthcare problems. They are also starting to give the GATE biomedical paper. So except for the industrial engineering, electrical engineering, students like that, as I said, there are roughly 12 marks in engineering mathematics. And most of them have an aversion. The point of this discussion is to make sure that if you have just the guts to approach the can get about X marks just by honestly and bravely approaching the question and trying to answer. What I mean by that, I'll kind of elaborate as we discuss the solutions, but being brave enough to read the question and sincerely giving it an answer. If you do that properly, you can actually get around 6 marks. Engineering mathematics is a kind of easy in that sense. If you are good at math and plus you also have prepared really well, in that case, getting around 8 marks and all that is. But our objective today is to actually deal with it majority was trying to get the 6 marks. BM students don't want to lose an edge because of engineering mathematics. BM students as well as MBBS doctors. In engineering mathematics is one place where this INE students can get an edge and have an edge. Again, they don't want to miss it, right? So in that sense, what is some simple, sensible things, brave things we can do to grab this 6 marks? Bare minimal things that we need to do to grab these 6 marks. That we are going to discuss today. And I am going to give a lot of illustrations using PYQs from GATE biomedical paper, specifically from 2020 to 2023. 4 years of PYQs I'm going to. I'll start with basic theory. Basic theory as in like the bare minimal things that you need to know to understand the question, to answer it reasonably. It's all questions. And mathematic questions specifically, there are some interesting weaknesses to mathematics question, not to the students, to the questions that can be, and the answers could be found easily. So I'm going to address many of those weaknesses, most of the weaknesses in the that can be exploited to quickly answer them. So we'll do all of that. Notice I already have put up a video that 80% of questions show up from 20% of concepts, right? So even if you look at a video like this, idea is every year about 80% of typically the scenario in many things, 80% of from 20%, a small cluster of the entire syllabus, 20% of concepts. It so happens that questions or mocks, you could say also mean, or it so happens that I'm realizing as far as the biomedical paper is concerned, students have a feeling, sir, if 80% of questions or mocks show up from 20% of the concepts, you're already saying one or two questions are not really, they are very too hard for the gate paper. Okay. One mark question, two mark question, right? It's too hard for it. Now the questions they have is, sir, is there a percent of 40% of marks can be scored? This is a 40-50%, even 40-50% of it is slightly actually higher than, I would say, something around people, roughly the 6 marks that I was mentioning to. There any 10% of concepts, right? From 10% of concepts. This is the questions that student. My answer is very strong, but it's just not a matter of concepts that are kind of clustered. It's also a matter of the knack of answering questions, mathematic questions, exploiting questions weaknesses and answering them. And this is what I'm going to discuss today. Or some bare minimal things. If you understand some terminology, if you understand the question, if you can recall some basic, you can answer many sufficient enough to either get a edge or to hold your edge, hold your seat. And the competition is relatively easy, but still it's very competitive. You don't even want to miss a mark or two. Specifically the easy marks, you don't want to miss. And that's the objective. Let's quickly get started. So I'll do most of the 10% of the things. Most of these concepts will be covered in this one topic. The statistics alone I'll cover separately. I'm not planning to do a part 2 video, but I'll cover that separately. I'll put that along with uncertainties and error quantification, and so I'll club the statistics and that together because they are very much related, and I'll make a very separate video on that, not part. So we'll do most of the PYQs, in fact, all of the PYQs that are showed up so far from these topics. Okay, that's the objective today. And let's quickly get started. Can you do a quick check? This fine. Okay, so most of you are here. So first question, some questions on basics of math. So given x is real, identify all the even functions among the. So given this notice in aptitude, there are questions, miscellaneous questions show from mathematics. We already discussed them but quickly notice equation of the visual graphs. Back and forth from this. Given a graph, can you find given the function, can you find the graph? There are typically questions like this. We have seen some examples on that. And in those cases, what we typically do is we check for, the things that we look for, or, let me also give an example. Okay. So equation is sin x, the function, let's say is sin x, graph here. Given this, can you get the function? Can you guess the function? Or given the function, can you guess the graph? Right? As easy as this, of course, but there are questions like that, right? given equation, find the graph, given graph, find the equation. So typically what we look for there is things like that. Special cases. What happens to at x equal to 0? Does a function and the graph match? What happens at x equals plus or minus? Where are the extremal points? Maxima, minima, where are they happening, right? Where are the extremal points? This is something that the slope 0 here is a slope 0 here. Then another thing that we look for is this thing called symmetry. Symmetry, repetition, periodicity, and all that, all right? Is there anything else that we kind of discussed in aptitude? Can someone recall? Extremal points, symmetry. In fact, there are many, many, many other things. One is monotonicity, convexity, tonicity. If you don't follow the definitions of this, it's immaterial. I'm just trying to recall a few aptitude things. Yeah, convex, concave, things like that. And today, notice we are going to start this in a bit of detail. We have two symmetries. One, an even function. This is a very, very, very optimistic function. What do you mean by that? Even if you give it a negative input, it gives out a output that is essentially corresponding to a positive input. Even if you throw in something negative inside it, it's as if it's blind to that negativity. It's very optimistic, full of positivity, right? Don't see any effect of the negative sign. Then there is this another class of how this looks. Quick example for this is the cos x function. Cos function, notice, looks like that. For any value of, say, positive x, this is a function value. At the negative x, the function value remains the same. Notice the function value remains the same. Despite input is positive or negative, the value remains the same, right? So this is what we refer to as an even function, optimistic function. We have this class of negative functions, pessimistic. They actually refer to as odd functions. And what we have here is essentially you throw in a negative news or something like that, negative input to it. It comes back with a negative. For example, here, notice for this x, output is positive. For the negative x, output is the negative value. Take this value, put a negative sign to it, get a negative value. And visually, they have some certain symmetries. One about this y-axis and another one looks kind of rotated, right? So this is what we refer to as an even and odd. Here, you need to recognize as few basic things. I'm not going to list down everything, only very basic things. There's even and odd function, right? Notice they have whether there is a negative sign or not is what differentiates them, right? There is a negative sign here, right? That's what differentiates them, right? They behave like and minus. In that sense, if you take two even functions, if you multiply them, they behave like plus and plus. What you get back is an even function. To take odd function, into an odd function. Product of two x into x is a product, right? What you get is an, notice they behave like negative functions. Minus sign, minus into minus, you get a plus. Interestingly, product of two odd functions will be even. Okay. I have just written the plus beneath only the colored one as the equation. I'm not adding e plus o minus and all that. And we have these two things. If you take a plus, if you multiply with a negative, of course, what you're going to get is a negative. Even and odd would be odd. Again, odd into even would be, this is minus into plus. Again, you are going to get a minus, that is an odd function. Simple. The reason to do that is these are all can be seen as products, or I'll come to that in a moment. But if you look at these into, let's look at parts here. I want you to classify the parts into odd and even functions. So even functions here, some of the even functions that I see here, mod x, absolute by definition, doesn't know any negativity. It doesn't have any negative sign by definition. It always throws up a positive value. I showed you x, even function. Can anyone see, is there any other even parts here? Similarly, what we also need is odd parts. Let's also list them down over here. Are there any odd parts here? Quickly, if you plot this, plot x, t value is, in the side it's negative, right? So this notice is an odd function. This is f of x equals x. This is an odd function. Let's also look at this. Notice this mod x as a symmetry, even this is mod x. Are there any other odd functions here? I just noticed retains its sign. So x is an odd function. 1 over x is an odd function. And yeah, x square is an even function. At this stage, with no calculations, none of that, we can quickly go ahead and answer this question. This is odd into even. 1 by x is odd. It retains the negativity, right? Negative sign. So this is odd into even. These two, they're very separated. Function, the input is even. The input is always positive. What goes in is through a lens, positivity lens. What comes out to be even. Or any function, the input is positive. It retains that positivity. Here, the input is even, x square. Composited, that is, it goes into another function, sign. Doesn't matter what that function is. What goes in is even, what results is what goes in is even. X is the input to the exponential. Doesn't matter whether exponential, sine, cosine, tan. It retains the input's positivity. So this what goes in, notice. That part is what goes in. That part is even. The input is even. So this is an odd function. A is an odd function. B is an odd function. C and D are correct options. questions, there's a quickest way to answer this question that we just discussed. Okay? And almost every 2 years, there is a question on even odd functions. And this also kind of intersects with signals and systems. So there are questions on that. And then you could go and ask, hey, what happens to a sum of even and even function? What happens to a sum of odd and even? That is now getting outside of the 20% domain. Okay. But with this, if you kind of follow this repeated question concept can be easily answered. Okay. Let's go on to linear algebra. What are the bare minimal things that you need to know? So far, there aren't any questions from systems of linear equation. That's very important, but so far it hasn't shown up. Let's just, for the today's discussion, let's put that aside. You have definition of an eigenvector and an eigenvalue. um, it's a matrix. X is an input. Output looks like the input. Scale by a scalar value. Here, we refer to as X. Any lambda that satisfies this equation, we refer to this as an eigenvalue. Corresponding X is an eigenvector. And what you need to know is definition. Trace of A. This is summation of eigenvalues. Number 2. Determinant of A happens to be product. I'm going to use this pi as a product of eigenvalues. If any of you are like kind of slightly confused, let's say product of eigenvalues. For lambda I, its product. Okay. Here you need to understand two. Notice one point is, we'll come back to this in a moment. One point is, this implies A minus lambda I, determinant of that is 0. Even something like what is determinant, I'll quickly address that with a very, very simple. More interestingly, so if lambda I or eigenvalues of A give me any matrix function of A, it has, typically this is a non-invertible A, but any function of A, let's say. Eigenvalues f of lambda. If lambda is an eigenvalue of A, f of lambda is an eigenvalue of f of A. What is f of A? For example, square of A square, right? Lambda square will be eigenvalues. Quickly, with this, notice, so eigenvalues of a 3 by 3 non-singular matrix P are 1, 2, 3. The trace of matrix P inverse, the function given here is P inverse. F of P is essentially inverse of. So f of lambda I, notice, are inverses of the individual eigenvalues. 1, 1 by 2, 1 by 3. Whatever is this function, right? The inverse function. I have applied that. And we also know that the trace happens to be the sum trace of P inverse equals 1 plus 1 by 2 plus 1 by 3. Quickly, how much is this? 1.83. Quick, the trace also happens to be sum of diagonals. This also equals to sum of diagonals of the matrix. Don't have to, finding trace is very, very easy. Look at the diagonal elements, add all of them, you get the sum of is also equal to sum of diagonals. Now, if you look at this problem, instead of trace, they could have asked you to, and instead of 1, 2, 3 as eigenvalues, they could have, eigenvalues of P. Instead of P inverse, they could have given you any P square, any polynomial of P, exponential of P, trigonometric functions of P, anything they could have given. They could have asked you for, again, the trace and determinant or even the eigenvalues. Okay, let's look at one more question here. Trace and determinant of a 2 by 2 non-singular matrix A or 12 and 32 respectively. Eigenvalues of A inverse. We know the trace, know the determinant, right? 2 by 2 matrices, 2 eigenvalues. If you find the eigenvalues, you can find the eigenvalues of A. Fairly easy. So what is given us for the original matrix A, lambda 1 plus lambda 2 is, this is trace of A. Determinant of A. This is just a product. This is lambda 1, lambda 2. They haven't given the matrices, but they have given information to find the eigenvalues, right? Lambda 1, lambda 2 happens to be 32. Now we have to solve for this. So notice lambda 1 into lambda 2 will be 12 minus lambda 1. Happens to be 32. Can you someone solve for lambda 1 and lambda 2? Tell me what this is. This happens to be lambda 1 minus lambda 1 square equals, if you take it to this side, just tell me lambda 1, lambda 2, and then we'll go there. I think this is 8 times. If you notice, you could write this as that I do have reasonable space, right? Write that as lambda 1 square minus 12 lambda 1 plus 32 equals. So we have lambda 1 minus 8 into lambda 1 minus 4, completion of squares. I'm presuming you know this. You have to find the roots of that. Even otherwise, if you don't know, you have this formula for roots of the quadratic equation, right? You can use that. Okay. So the eigenvalues are lambda 1, lambda 2. In the previous question, they had given this. Here, let's say, as eigenvalues of 8 and 4. Eigenvalues of A inverse. So let's also kind of write that. Eigenvalues of A inverse would be 1 by 4. The operation, matrix operation as function is inverse. So again, 1 by 4 and 1 by 8. That corresponds to option D. The function again is they could have given any other function. And only thing they did is instead of giving the eigenvalues of A, they gave you information to find it. And they gave you trace and determinant. Only two eigenvalues you can easily find it. Because A is 2 by 2. Now, brings us to here. The set is very large, right? Eigenvectors specifically is very easy to deal with. Many questions from that. Differential equations again is very easy to deal with. These two specifically, because you can often use a definition and verify or eliminate the option. For these two specifically, know the definition and easily score most of these questions, if not all. Let me show you a quick example. And I'm kind of highlighting that in the entire syllabus, those two. Question shows up, your first question is, can you verify your... Which one of the following vectors is an eigenvector corresponding to the eigenvalue of matrix A? By definition, A times X should give back that X. In this, X is a vector. A times this, whatever this vector is, what that equation says is specifically times the X is, in this case, the eigenvalue is 1. You should get back the same vector. There are 3 numbers here. 3 numbers here. The same 3 numbers. It's important. Do you know to do matrix vector multiplication? I presume all know. So now we are going to middle school or something like that, right? So matrix vector multiplication, I presume all of you know. Multiply the given matrix and the given option. See which of the keys open the lock, right? Very easy. Example, notice in this case, it's 0, 0, 1. I just, it's not like I know the answer key and I'm saying that. This is because 0 times the first column. This is one way to do the matrix vector. 0 times the second column, 1 minus 1 minus 1. And then 1 times the last column. This is A times 0, 0, 1. What I have done is matrix vector. Clearly noticed this term is 0, this term is 0. What is left with is 1 times 0, 0, 1. A term that I was looking, and that makes this as the answer. If you're not satisfied, you can plug this. You wouldn't get 1 times this number. You wouldn't get 1 times this number. You wouldn't get 1 times that number. So here I have plugged in A numbers here are 0, 0, 1. I'm getting back 0, 0, 1. I have done this, use the definition and verify. See, in aptitude, we did a question like this. I if looking like too complicated, probably terms are getting there are many zeros. So things will simplify. The Hulk kind of becoming a simple, right? Whole thing. So we had this, if I had to again recall, there was this, hey, if r square plus 2x plus 3 is 0, what is product of r square, say r plus 2 into r plus 3 into r plus 4 into r plus 5? That product has many, mostly zeros. You can easily cancel them. In fact, you can go on and on because it's zero is it will easily cancel and you can find it. A similar thing can also happen in the respect to already said you have ax equals lambda x. This implies determinant of a minus lambda I is 0. Is there an example where we can see that? Okay, determinant of. For example, this matrix is a minus q minus lambda I. The determinant of this is 0. If you know how to take a determinant of a 2 by 2 matrix, notice this is a polynomial in lambda. Okay. So in general, this equation is a polynomial in lambda. The roots are eigenvalues. You could write that in, few forms, right? Equivalent forms. Polynomial lambda, this is typically f of lambda equals 0. Lambda square plus 2 lambda minus 3 equals 0, something like that. Okay. Simplest case, again, let's do like, a 2 by 2 matrices. Lambda square plus 3 lambda plus c. Complete this. If you complete the square, you'll get it this as lambda minus lambda 1. The roots are lambda 1, lambda 2. The eigenvalues equals 0. You'll get it in this format. So far, fairly easy, right? Determinant of a 2 by 2 matrix, you're getting a polynomial. There is something called Cayley Hamilton. This instead of lambda, you put the original matrix, the equation holds good. So instead of lambda, I put a square. Instead of b lambda, I put ba. Instead of c is a matrix equation, so c times I equals. This is referred to as the characteristic equation. The matrix satisfies its own characteristic equation. That goes by the name Cayley-Hamilton theorem. Notice this is an equation that says something is 0. It's easy to cook up problems with this. You can easily find a power 4, a power 10 and all that very easily. You can find a inverse. This term is 0, multiply by a inverse. You will have a here, you will have a ba here, you have c a inverse. You can easily find a inverse. You can find many things using this equation. One such example is this. The given matrix is A and then identity matrix. What is A square is Ka minus 2i. So all it says is, see, any power of A can be expressed as lower powers of A. In this case, it's a 2 by 2 matrix, power 1 and then a constant, right? So whenever you're looking at a polynomial for matrix, what you should think of as Cayley-Hamilton theorem. In this case, find the eigenvalues and substitute instead of the eigenvalues, instead of the lambda, let me do an example. You have A minus lambda I is 0. So I have 3 minus lambda minus 2, 4 minus 2 minus lambda. Determinant of this is 0. That implies I'm going to, these two, there are two negatives there. I'm going to cancel them. What I have here is lambda minus 3 into lambda plus 2 plus 4 equals 0. If I simplify this a bit further, I got lambda square minus lambda plus 6 4 equals 0. Is this lambda? I suppose there is a minus there, right? Minus 6. The characteristic equation here, characteristic equation there is a 4 into minus 2, minus 4 into minus 2 determinant, right? Thanks. So there is a 4 into 2 4 into 2 equals 0. This becomes 8 equals 0. The characteristic equation for this problem happens to be lambda square minus lambda plus 2 equals 0. Cayley-Hamilton theorem says if we replace lambda with A, equation still holds good. So you have A square minus A plus 2i equals 0. And easily find A square, right? A square happens to be A minus 2i. So matrix polynomial, the moment you look at a matrix polynomial, inverse is a matrix polynomial, right? 1 over x, matrix polynomial. First question is it Cayley-Hamilton theorem? I am presuming you can do this multiplication of, this algebra. I am presuming you could do completion of squares. There is even no completion of squares. This determinant, this multiplication, I am presuming you can. So in this case, the answer is K has to be 1. Coefficient of A happens to be 1. Notice, also ask other things fairly easily. For example, A inverse, you find that if you multiply by A inverse on both the sides, I get A equals I minus 2A inverse. I can solve for A inverse very easily in terms of A and I, lower powers of A, right? So you can find A cube, A power 4, all of that. Polynomials are fairly easy to do because of Cayley-Hamilton thing. Okay. This question, which one of the following statements is true? Q is equal to its transpose. Q is equal to its. The transpose is fairly easy. This is to find eigenvalues. You don't need it. Lambda I. You have to solve determinant. Let's not worry about it. Notice Q transpose, most of you would know. Q transpose here happens to be 1, 2, minus 2, 1. Q is not equal to Q transpose. Slightly, somewhat of a very hard concept, but I'll put that in simple English. Q is full rank. There are 2 columns given. There are columns given. One column is scalar multiple of another column. For example, if one column is 1, 2, other column is it 1, 2 or 2, 4, multiply 1, 2 by some number. Is it that? No. Something entirely different, right? So these are very different. Because of that, it is a full rank matrix. In other words, one is not dependent on the other. Columns are linearly independent. Q is equal to its inverse. Now, it boils down to what is Q inverse. At least know the inverse of a 2 by 2 matrix. You have the matrix A, B, C. If you take inverse of this happens to be 1 by D minus BC. This is just a number, AD minus BC. That times D minus B minus C. What I have here is, what I have written as A inverse equals, inverse of a matrix is 1 by determinant of A into adjoint of A. Okay, determinant of this, if A is, A, B, C, D, determinant is AD minus BC. That all of you know. That's what I have there. Then what is this adjoint matrix? This is transpose of something called the cofactor. Adjoint of A is transpose of something called a cofactor matrix. What is it, cofactor? That is, for A, it is the other term. Leave A, for a 2 by 2 matrix is the other term, D. For B, leave this row, this column. What is left is C, right? C, again, leave that row, that column, the other thing. For D, the cofactor minor is A. Is a cofactor matrix. And in high school and all that, you might have remembered this. This is a plus, this is a minus, this is a minus, this is a plus. Plus and minus keep repeating alternatingly, right? So we have these signs. Notice if you take transpose, you end up with this matrix. If you take transpose, that is, you end up with the adjoint. It happens to be the adjoint, that is the transpose matrix. If you know this, and at least Recognize the basic definitions. A is a cofactor, is adjoint, is a determinant for 2 by 2 matrices. So inverse in this case is what? Color did we use for inverse? A inverse. Quickly, Q inverse happens to be 1 by 1 plus 2, 1 plus 4. So this is 1 by 1 plus 4. That's it. And the matrix, adjoint matrix here is 1. And this is 2 minus 2. Is equal to is inverse? No, this is again not equal to its inverse. So there is only one correct answer. That is the rows are all independent. Okay. Integration differentiation. So let me recall what I said. There's eigenvectors, verification, elimination, differential solutions of differential equations. 4 options are given. Which one is a solution? Quickly we can verify that, right? Even you can do that for partial differential equation. If you remember basic integrals, you can solve questions like that. But even otherwise, say I forget the basic integrals. At least try to eliminate options. I try to eliminate at least one option. Notice there is a function of x minus 1, first 2 options. Second 2 options are functions of x by 2. Has to be one of that. But a quick ways to eliminate with a little bit of algebra. Notice this happens to be, let me try to complete the squares. So if I add a plus 1 and a minus 1, what I have here is this is x minus 1 whole square. At this stage, you will have to make a substitution of, y is x minus 1. So you are going to get a function of y. Solution is a function of y. This is not a function of y. This is not a function of y. Or this is not a function of x minus 1. That is not a function of x minus 1. You know what is integral of dx by square root of 1 minus x square? You can substitute and do that, or you can also directly write this down. This happens to be we don't know. Most of you are going to be at this stage. So eliminate 2. Guess one among the, you eliminated 2. So it's worth guessing at this stage. This integral happens to be sine inverse. Don't lose out this edge. I eliminate 2 options. That's a very strong edge. Do a lot of math. I also put myself in the shoes of most students. And this in high school, if you forget it, fine. But still, it's either A or B. In this case, I know the integral is a sine inverse x minus 1. Again, if you know the derivative of sine inverse of x minus 1, there also you can answer that. But do we know the derivative of sine inverse of x minus 1? Inverse of x or sine inverse of y, right? Fine. Solution of the differential equation. That is, if you put the solution, it should LHS should be equal to RHS. That is what makes it a solution. Is for which of the options is it A, B, C, or D? The LHS equals RHS. The solution should satisfy this. But one tip, eliminate for verification. What do we mean by that? So there are two terms. There are like, whether is it e power x or e power minus x. Okay. The RHS has no e power x. It is getting cancelled. So dy by dx minus y, the e power x term should disappear. Derivative of e power x is e power x minus the function, it disappears. Term disappears in the LHS. In the RHS, it's not there. This term wouldn't disappear. This term wouldn't disappear. Derivative is minus e power x. Function is e power minus x. Minus e power x minus e power x becomes minus e power x. E power minus x, right? It is not there in the RHS. It's not disappearing. For that reason, I eliminated. Now, instead of 4 options to verify, you only have 2 options. I saved my time, right? Made it half the time. Eliminated. And again, derivative of e power x, I'm presuming all of you know that, right? Oh. Verify, only 2 options. Is it A or B? Here, notice, let's write down dy by dx. This is going to be cos x minus of minus sin x by 2 plus c e power x. If I add this term, if I subtract this term from this, sin x will disappear. The cos x will become cos x by 2 minus of minus cos x by 2, that is plus cos x by 2. I get a cos x. I already noticed this and this will disappear. Option B. So notice, verify an answer. All of you know that you can save almost half the time by eliminating it. Save time. Let's do some basic things. And sign up. Know at least this much. Then at least, I would know the polynomial. You know this, you also know the integrals, right? You can go the other way around. This side is a derivative. Undoing that is the antiderivative, right? If you integrate e power x, you get e power x. If you integrate cos x, you get sin x. So that, presume, at least this. Value of the double integral is corrupt up to 3 decimal places. X by dx dy, where r is the first quadrant of the circle with center of the origin, radius of 1 unit. Radius of 1 unit, it's a circle, first quadrant. So this is 1, this is 1. I have to find the product of xy and kind of quickly do this in two ways. And questions kind of target both these two ways. Do a strip like this, first integrate in a strip like that, moving that square up and down, and then moving the strip left and right. Could also do it in a strip like this, by first moving that square left and right, then moving the strip up and down. Okay. This is a double integral. Some function, a variable function, it has two inputs. First, you are moving up and down along y direction, the blue. So first you do ty, then you move along the x direction. To dx. You could also do it this way. First, you are moving along x, and you are moving along y. Both of them needs to be equal. The integral of the same thing. There are two ways to reach, the same destination. What is interesting is the limits here. For this problem, notice the blue will vary from lowest value is 0. What is the highest value for the blue? Highest value of y function, in fact, at the top is y equals square root of 1 minus x square. In the circle, y value is that. Here, what is the highest value of x? We're moving the green square. That is x equals square root of 1 minus y square. Same circle. Highest there, y varies from 0 to square root of 1 minus x square. I did that first. Here, x varies from 0, square root of 1 minus y square. And then what is y varies from? Y varies from, sorry, this x varies from minimum value is 0, maximum value is 1. What is the y vary from? Minimum value is 0, maximum value is 1. So I took the unit circle as the example. This value is 1, this value is 1, unit circle, this value is 1, this value is 1. These four numbers big questions in themselves. How do we know the order? Because notice, by convention, we write these in different orders. Know this, rest of the integral, I presume you can easily do, else, skip this question, but know this difference. What I have shown here, know. Go here, you can technically do that in any way. Let's do it in one of the ways. So first I'm going to do the green up and down. Then I'm going to do the blue up and. So the green top is, it varies from 0 to the top, it's 1 minus x square. First I do dy, I do dx. Limits are y varies from 0 to square root of 1 minus x, and then x varies from 0 to 1. Can we quickly complete this? We'll give you a couple of minutes. This stage, if you know, do it else, you don't have to do this. So first, as far as the integration of with the dy concern, the x is a constant. You don't have to worry about it. You can, in fact, write it this way. You can also take the x outside of that. First, you are integrating x is a constant. It goes out of the inside integral. Constant, it came out. The limits are 0 to square root of 1 minus x square. Integral of y is y square by 2. Let's get that. Half y square by 2. The half came outside. It's that. And then I have x. What is that? Y square by 2. I have y square. 2 came out within the limits 0 to square root of 1 minus x square into dx. Put 0 there, it's the 0. So only the positive thing sustains. So that happens to be 1 by 2 into, from 0 to 1, x into, if I substitute the upper limit, that becomes 1 minus x square. Lower limit is 0. So I'm not going to bother about that. Dx. So this is 1 by 2 into x dx is x square by 2 cube dx. That would be x power 4 by, the limits are from 0 to 1. So there is half minus, if you substitute, this is the inside term is half minus 1 by 4, that is 1 by 4, gets multiplied by 1 by 2. What you are supposed to get is 1 by 2 into 1 by 4, that is 1 by 8. I suppose that is 0.125. What is important is what I showed here. If you follow that, fine. Else, is a 20% of not there in the 10% of concepts. Skip it. Sanity checks. Okay. See, differential equation, I can tell you one thing. It's already easy. I told you it's either, given solutions, it's fairly easy to do, right? Say dy by dx, some function of x, right? The answer is a function of x. Notice this is a function. Where your LHS should be equal to RHS. If you plug in that right function, your LHS should be equal to RHS. So multiple choice questions, you can verify this, right? In MCQs, there is one correct solution. And sometimes, don't get threatened if you look any complicated differential equation that you are not able to solve, ask whether they are asking for a value. They're not asking you for the entire y of x, or are they asking for a particular value? This is value, not a function, at a particular x naught. Say 0, at infinity, at 1, 10, and all that. This is type 2 problem, and this is finding a value, instead of that function, you're finding just one value, right? Fairly easy, often easy. Example, this question. Suppose this is what is referred to as a logistic equation. Time-dependent growth of a bacterial population governed by the equation. dx by dt is x into 1 minus x by 200, right? Population is given, initial condition is given. As t tends to infinity, population size of the bacteria asymptotically approaches. That is, they are not asking you for what is x of t. They are not asking you for this. They are asking you specifically for x of t tending to infinity. Let me write it as x of infinity. Value, they are not asking you for a function. Asking you for a value. Often this is fairly easy. If you are suddenly threatened by this differential equation, sudden rise in heart rate. No. They are asking for one value, not a function. Might be easy, right? The next giveaway is asymptotically reaches. That is, it kind of doesn't change. Asymptotically, things don't change. It says asymptotically, it has kind of reached a saturation. Things are not changing. dx by dt actually is 0. Is what asymptotically happens, right? So they are asking you for solutions of what are the roots of this equation? Asymptotically, there is no change. dx by dt is 0. What is left is this. What are the roots of this equation? Okay. This has two roots. One is the x is 0, another one is x is 200. In fact, x is 0 is nowhere over here. Confusion. Only 200. There is only two roots possible. X is 0 or 200. The answer has to be the value they are looking for is 100. Another differential equation is given. This is actually somewhat of a signals and systems question, and I also need some Laplace transform. So I'll come back and do this question. One, calculus applications. Calculus applications, we all know. Finding maxima, minima, right? Integral, finding areas, volumes, and all that. Finding maxima, minima, maxima or minima. And then finding areas and volumes and things like that. Finding areas, volumes, so on. So maxima, minima, extremal points, be careful. Your first derivative is 0. Case, of course, you have to check for first important trap. Students don't check the second derivative. Is it a maxima or a minima? Right? Trap is set. So for a minima, maxima, f double dash is greater than 0. for a maxima, double dash of x is less than 0. So if you have a function like this, if you look at the slope kind of increases. So rate of change of slope is positive. That's a maxima. This is important. This is a typical trap one. You all know to take a derivative, but the trap is set there. The second trap is you also need to check the boundaries. The boundary is given. Check what happens in boundaries. If you don't do that, maxima or minima that you are looking for can be at a boundary, which typically is the case because a trap is set at the boundary. They know students are going to look for this. Having said that, let's look at this question. For a function f of x is x power 4 minus x square, which of the following statements is are true? Function is symmetric about x equal to 0. Function is an odd function. Minimum value of the function is minus 0.5. Function has two. While I'm going to address, so two options are concerning maxima, minima. Two other options are concerning odd function and symmetry. Function is symmetric, even or odd. Think about this. Justify that. While I justify that, let me do all the derivation, first derivative, second derivative, all of that let me do. Then we'll quickly address the other. Of x, even or odd. Okay. We discussed initially, you should be able to answer this. So note as the other thing, right? No boundaries, no traps here, so you don't have to worry about it. F dash of x happens to be 4x cubed minus 2. If you set that to 0, you are going to get 2 in 2x into 2x square minus 1. Suppose the solutions here are x equal to 0 or minus 1 by root 2. Not fall for the trap. Let's find out what is the f double dash of x. That happens to be 12x square minus. Okay. So the plus or minus is irrelevant. They're asking for the function has a minimum at 0.5. No, at this stage, there isn't any minimum, right? This is x squared. 4x cube minus 2x. This is plus or minus 1 by root 2. This is not the case. Because extremas are happening at 1 by square root of 2, not 1 by 2, plus or minus that. The function has two minima. Note as square, right? The sign, this is that positive function, even function that I was referring to. So if you put plus sign, negative sign, doesn't matter. So how much is this? Number 12 by 2 minus 2, 6 minus 2. This is greater than 0. The function has two minima. Typically plus or minus 1 by 2. Function has two minima. Is it even or odd? Notice quickly. Hey, this is an even function. In fact, constant is an even function. It looks the same way, right? If you add two even functions, two positive functions, they remain is not multiplication. Addition, adding two even functions remain positive. This is even. Power of 4. Power of 2. Again, even powers are even. Odd powers are odd. 1x. X power 1, that is odd. X power 2, right? The minuses get cancelled. So this is even, this is even. The function remains an even. There is actually symmetry about x equal to 0, but it's not an odd function. It's rather an even function. So that kind of wraps up the even odd function discussion that we had. So now, hey, what happens is the sum of some differences of two even function has to be even. Some differences of two odd function has to be odd. Even an odd function can be like, you cannot really have to be careful. In fact, often it's neither even nor odd. Things remain odd, negative things remain odd. E plus or minus odd. This is neither E nor odd. U, E or O. Be careful. Calculus, again, the questions typically repeat. First derivative set it to 0. Make sure you check the second derivatives. Either the trap is there or need to check the boundaries. F of x is e power x cos y. What is the value of square f by dou x dou y? This is something that is very, very easy, basic definition. Again, make sure we know that. It has two in. For this, behaves like a constant. Treat it as a constant. Or you are looking for changes here along y. Changes in x. X behaves is immaterial. X behaves like a constant. And what this gives us, change along x. Change purely along x. Change. Let me also now let's get a slightly better contrast. Change. Derivatives change purely along this direction. That to y behaves like a y. Changes in y is immaterial. X direction. So if you look at this along x direction, purely along this direction, and then you have changes along y direction. So your f of it's a function of two variables x and y. This is e power x plus y. O f by first you are doing it with kind of immaterial, but let's say first with respect to y. X is a constant. Power x is a constant one. Any function of x immaterial. What is the derivative of cos y? Just looked at it. Minus sin y. So your function minus e power x sin y. Let's give it some colors to the stage. You take this dou by dou x of this thing, dou f by dou y. Is this term. Okay. So now again you are going to take derivative with respect to x. Now y behaves like a constant. It behaves like a constant. Derivative of e power x, e power x. And you substitute x is 0, e power x is, this is, if you substitute, this term kind of becomes e power 0, that is a 1. Sin pi by 2, it's also a 1. I suppose the answer is -1 into -1. C. Hey, whether you're a doctor, whatever it is, 10th standard differentiation, all of you know. Y behaves like a constant, change purely along x direction. This, dou by dou y is x behaves like a constant. Just this one question or a couple of related definitions which show up each and every year. Can easily grab those. Oh, of course. What is the change along that direction? Combination of x and y, I and j. That can be answered. In fact, there is a specific definition of that. And let's quickly address. Before that, there's this minimum value of a multivariable function. Oh, f of x, you are checking f double dash of x and f double, you set it to 0 and you are checking what happens to this single variable. In case of multivariable problems, you will set the gradient to be 0. If let's have 3 variables, x, y, z, 3 labels. You can say x1, x2, x3, x, y, z, y1, y2, y3. 3 the gradient. And then of course, there are also kind of second derivative test, but let's that is not even 20% of concept. That will be like beyond the 20%. So let's look at what the gradient of f. Gradient, again, slope change in f. The top gradient of f. This just by definition, partial of that function with respect to f, take partial of that function with respect to y, take partial of that function with respect to z. This much in the I, this much in the j direction, that is this much in the x direction with a vector dou f by dou y, this much in the j direction, and this much k direction. This is the definition of gradient. Gradient of f. For example, in this case, it is the minimum value of this function. Take the so grad f. This is a vector. I'm putting this side. I'm putting this to say it's a vector. That is, it has I, j, k components. Let's say happens to be dou f by dou x1. I take derivative with respect to x1. Treat everything else as constant. I have to set this to notice. This is a vector. The I component, j component, y component is 0. You can look at it that way. This implies the I component is 0. So you have dou f by dou x is y component is 0, dou y by dou f by dou y is 0, and dou f by dou z is 0. In this case, there is x1 and then x2 is 0. Look at it that. Or let's take the gradient as we defined. If I take partial with respect to x component, right? This is x1 by 2, x1 minus 2. Rest of the terms are constant, doesn't matter. This much in the I direction. X2 minus 2, that is dou f by dou x2 in the j direction, plus 2 minus 2 in the k direction. Essentially, the ith component getting 0 led to the jth component being 0 led to each component is 0. So you can look at it either as a vector equation or 3 scalar equation, one and the same. So you have x1, x2, x3 happens to be 2, 2. Substitute it there. It has to be a maxima minima. This is like a x square, right? The parabola, this is a parabola that looks like this. It's not it's a square. It gets bigger and bigger as you go farther away from 0. X square, right? It gets bigger and bigger. It doesn't get smaller and smaller as you go away from the origin. It doesn't get smaller and smaller, right, as you go away from the origin. It does the other way around. It gets bigger and bigger as you go away from the origin. So it's an upward turned. It's a parabola that looks like. And let's remove it. It's a parabola that looks like this. And the minimum value happens to be, if you substitute 2, 2, 2, what is the minimum value? 2 square plus 2 square plus 2 square, 3 into 2 square, 3 into 4, 12 by 2, that is 6, minus 12. So that is minus 6. Evaluate this at 2, 2, 2. I'm going to get minus 6. That is the answer. And I know it gets bigger and bigger as I go away from the origin. So it's upward turn parabola. So I know it's a minimum. I didn't do the second derivative test. So in case of scalars, we had this. In case of vectors, multivariable functions, we have this. Gradient by definition is this. Magnitude of the gradient of the function at the point on comma 1, right? Dou f by dou x happens to be 2x. Dou f by dou y happens to be 2y. The gradient of f, this is a vector, this is 2x in I plus 2y in j. What they want is, again, the definition fairly easy to do. Gradient of f at 1, 1. X is 1, y is 1. That is magnitude, right? So they want, okay, let's find the gradient at that and then we can write the magnitude. So this is 2i. It varies from location to location. When x is 1, y is 1. This is 2i plus 2j. What is the magnitude of that? And this says magnitude of grad f equals square root of first component square plus second component square. 2 square plus 2 square plus 4. So 2 root 2. 0.82 up to 2 decimal places. This is 2.83. So gradient changes and multivariables you can use. You can treat it like a first derivative. Definition is this. It so happens that and also get changes along any direction using the gradient. Notice if you take gradient, dot it with a direction, let's say unit direction, I. What I'm getting is change along the direction. Change along x. Get change along y. Yes? Dot it with j direction. Take that vector, take dot product. Dot product, I am presuming you know. If you don't know, I'm sure you're not watching the video by now. So dou f by dou y is along y. And you will dot it with an arbitrary direction, n vector. Unit, I put a hat to say it's unit. This gives you, we refer to as directional derivative. Change this directional derivative along. Let's highlight that. This will give you directional derivative along unit direction. Unit is, has to do with that. That is, its magnitude is 1. Unit direction n hat. Any direction give me, I can find the change along that, not just along I or j. I cannot only take partials along x and y. I can take partial derivative along any direction. I can find change along any direction. How much is the, you're somewhere in the mountain. How much is the change slope in the x direction? How much in the slope in the y direction? I will walk northeast, southwest, combination of, south, southeast, something like that, right? You can do all of that. Second use of it, for example, given a scalar function and two variables, directional derivative of v, direction of the vector field 3yi minus 3xj. A direction fine, I'll find its unit thing and I will, what you have to find here is, let me recall, take this, dot it with direction of interest, but make sure it has a hat. And that is, make sure it has a event. So 100. Grad B happens to be 2x, sorry, not here, the 2 will get cancelled, xi plus xj. I plus yj. The n in this case is pyi minus 3xj. The n hat in this case, okay, notice n to put a hat is that divided by its magnitude. Okay, divided by its magnitude. Now it's normalized. It's made a unit vector. For example, n hat equals 3yi minus 3xj divided by the magnitude. That would be square root of, 3 I think will come outside, square root of y square plus x square. Of your roundings are yx square plus y square. So to be on the safer side of explanation, description, y square plus x. First component square plus second component square. First component square is 9y square, but 9 came out as a 3. You can take, now, we can find this del v dot hat. Evaluate, what we specifically want is evaluated at 0.1 comma 1. Okay, that happens to be xy minus dot product x into 3y. In the x into 3y, I dot I is 1. Y into 3x or y into minus 3x, j dot j is 1. So minus 3xy by, what do you get here? If you evaluate this at 1 comma 1, if you substitute x is 1, y is 1, looks like things are cancelling. 3xy minus 3xy. 0. Any point this is 0. Hey, might look threatening. The whole point of this is, if you gather this, heart, if you're brave enough to approach it, use a definition. If you know the definition, notice it looks kind of like big and all that. Oh, by the time I find X, Y, and all that, right? Will the exam get over? No. Right? This stage, notice my 1-page rough sheet is over. Just in case it's something, yeah. First of all, they given you 1 comma 1. Even if it is not 0, numerator here is 0. If it's not 0, you can quickly substitute and find out. Right? I'm not really running into pages. So, if you have the heart, these marks are gettable. Okay. That edge means a lot. Whether you like engineering mathematics or not, whether you feel you know, whether you prepare on all that, irrespective of all of that, these marks are scoreable. And if you score them, it's though any edge gain there is well worth it. In terms of what? Typically in terms of IITC, weight in gold. Some perhaps it's actually no more precious than gold, let's say. Let's, you know, gradient, what you have seen is so far as first derivative test. Like you can get directional derivative. You can also get surface normal. There are three applications for gradient, at least so far. Square plus y square equal to 4. This is a circle. Square plus y square plus z square equals, say, 4. This is a sphere. Notice surface, sphere is a surface, right? They have equations of the form f of x comma y comma z. If you take gradient of that, you'll get surface normal. Let me note it down. This is a circle. That's a curve. It's a sphere. That's a surface in 3D. So these are surfaces. Sorry. In general, what I want to say is a function of x, y, comma, z is referred to as an implicit function. This is how surfaces, this is one way to describe surfaces in 3D. If you take gradient of that surface, get normal to that surface, normal vector of that surface normal vector. One more application. So far, no PYQs, but given a surface that is given an equation like that, hey, what is a normal at any particular location? You can quickly find out is normal. Then comes a question. The equations are getting, again, the solutions are getting easier in a way. Quick bit of, this needs a bit of, hey, and where am I? Complex variables. Yeah, I schedule for 3 hours, so go. Used to this. What is the antiderivative of this? Most of you know that is an integral. That is inverse of taking derivative. What is it? You are doing an inverse, integral, right? What is the definition of integral? Notice. This you are going to get for b minus f. You are getting back the function, right? what we used to, if these limits are not there, is f of x plus c, some unknown constant. That is, what operation should I do to a derivative to get back the original function? What inverse operation should I do to a derivative to get back the original function? You should do the antiderivative. That is the integral. This we know. If you put the limits, of course, this becomes a to b. For b minus f of a. These are inverses. Versus opposite actions, opposite operations. Okay. Let's get the integral a integral a to b f dash of x. Let's also give it some. Of course, there is a dx. So that I suppose like now that is just redundancy in notation, right? Gauss had this habit of putting this thing that becomes a function, right? Let's say Gauss actually was capable of putting a spiral, ellipse, and all of that there. Let's say this was Gauss integral. When you are doing that, you are not putting that, but everyone understands integral. Oh, you don't have that handwriting of Gauss, right? So you can afford to skip that. It's an integral is fairly clear. Like that, the dx there is kind of redundant. I already put an integral over there. Fine. So notice integral of derivative inside domain. Derivative side domain. Which is we have difference of functions at the boundary. This is difference. But if you want me to actually look at it as, say, if you do it with a proper sign, have in this side as summation of function at the boundary. Comma B is an interval. A to B is a domain. A and B are the boundary points. There are many generalizations based on this. Multivariable calculus. This goes by the name divergence theorem and corollaries. For example, this is roughly integral of function, let's say at a surface that's about that can be written as a derivative inside domain, inside that surface. The surface is a cone, so derivative inside that. So whenever I see a problem like this, I notice this is linear. So derivative is a constant. So I'm going to look at the equivalent inside. This is a divergence era. This is challenging Gauss. Okay. Function surface boundary equals divergence of a like that. What is divergence of a? The same, the simplest way to look at that is summation of function of the boundary. Yeah, summation of function of the boundary. So inside the domain, it has to be integral of derivative. Integral of derivative. Divergence is a sort of derivative. I haven't defined it so far here. So let me write it. That's fairly easy. I'm going to just write it. There is a put dot, right? Divergence of f happens to be just, it's a scalar. F by dou x. There is no I and all like gradient. The scalar. Dou f by dou y plus complications. Dou f by dou z. That happens to be. So the derivative is a constant. Why? You can pull out the constant in the RHS. You cannot do that in the LHS. You can do that in the RHS. So I went to the RHS. Let me see what that thing is. I already know this is 4. This term. Term 3. Hey, that term is 0. Last term also 0. Do, take derivative of z with respect to y, that's 0. Z is a constant. Take derivative of y with respect to z, that's a 0. And yeah, I have to be, this is little more careful. This is fx, xth component. Abuse of grammar, abuse of fine. I'll take all the blame. So yeah, this is yth component, zth component. So this is just integral of that volume. This becomes integral of 4 times integral of that volume. So notice this 4 times b. Anyone tell me the volume inside that cone? Let's kind of backtrack it this way. This becomes the 4 is a constant, came out. Volume of cone. Okay, cone height is 3. Cone radius. What is the volume of that cone? Equal 3. Radius is also 3 z square. This is volume of the cone. At any slice, it's a circle, right? Area inside a region inside a circle. As you change height, the circle radius changes. It results in a cone. 4 times volume of cone. Anyone calculate this? So 4 to 1 by 3 into 4 by 3 to pi into r square. R square is 9. Height is 3. We get here. One, 113. It looks harder, but at the end of the day, it's just a generalization of this thing. Integral of derivative inside domain is integral of function at the boundary. Summation is an integral. You can, say it that way. And why go to the take the derivative? Because if it's a linear thing, if you take derivative, it becomes a constant. It becomes constant times the volume of code. 113. Again, question shows up again and again from this divergence theorem and corollaries. It's fairly easy. Least simple English and definitions. Volume of cone, don't you know? If they ask you, hey, what is the volume of cone with radius radius is 3, height is 3. Can you not answer? That is what they have done here. Gateway of framing, they have framed it as a mathematical question. Which one is an invalid operation? Divergence, I know, grade, this is a vector, this is fine. Divergence. Divergence of a vector is a scalar. You cannot take cross product with a scalar, so that is invalid. So rest of the things are fine, I suppose. Answer this if you know what this transport equation is. Dou I by dou t c times dou I by dou x equals 0. It says y is a function of x and t, position and time variable. It cannot be any general function. Solution has to be of this form. It has to be, the input can only be this input. This is a forward and backward traveling function, shifted function. And the coefficient, coefficient of dou by dou x is c. C, speed at which the function shift. Speed at which function shifts. Transport equation is a coefficient of partial of x, not the partial of t. C equals 5. Initially, the function is sin x. The function can only shift if it is a solution here. Any other time, okay, at any other time, solution can only shift. That is, it can only be sine of x minus tt. What is saying is initial conditions, initial function keeps shifting. Keeps shifting. And here you can quickly find out what is y of t, comma, t is pi by 6. That is sine of I minus 5 pi by 6, that is sine pi by 6, that is half. In pi by 6, that is the half. Transport, you shift things. The equation shifts, transports functions, shifts functions. Complex variables. A reciprocal of the coefficient of z cube and the Taylor series. Taylor series expansion, let's make sure we know what that is. I can write any function as a polynomial expansion, polynomial series. Polynomial summation, finite summation. The coefficients happen to be nth derivative of the function n factorial. I'm going to repeat. I'm going to write any function. Idea is to write any function as a summation of polynomials, powers of x. The coefficient happens to be nth derivative. Nth coefficient happens to be nth derivative of that function evaluated at a, right? Yeah, the n factorial I already put there. This is just a summation of powers of x. This is nth. For example, if I stop with two things, this is f of a plus, this is zeroth derivative, x minus a power 0. First derivative, x minus a power 1 by 1 factorial. You can go on and on. There will be 1 factorial, there will be a 0. All of that is kind of 1. So I'm going to cancel all of that. Technically, this is also 1. X minus a power 0 is also 1. Goes to 1. So this is Taylor series, right? And if you don't know, you could quickly, find the derivative. You can find the Taylor series. So now notice, you could recall or the sine z minus z cube by 3 factorial plus z power 5 by 5. If you recall, you can answer the coefficient to be minus 1 by minus 3 factorial. Reciprocal of this happens to be this term, that is minus 3 factorial equals minus 6. That's the answer. If you forget it, so this is f of z. F dash of z. Yes. Z. First, let's do, says f of 0 is first coefficient is 0. Forget that term. There is no constant. And then f dash of z. This is cos. So the second coefficient, how much is this? f dash of z evaluated at 0 happens to be the third coefficient. F dash or double dash of z, that will be again f double dash of 0. This will be 0, so I'm not going to bother about it. And the fourth coefficient, f triple dash of z. Cos z minus sin z minus cos z. F triple dash of z evaluated at 0 will be minus 1. So there you could also derive that in case you forget the expansion. So sin z, cos z, whatever it is, you can always derive it. It's much better to remember this. This also actually the coefficient you can derive if you kind of recognize, if you know how to do partial fractions or something like that, you can also derive this coefficient. Not a big deal. You're all in the meeting. A complex number and probability, I think that's it, right? Some of you are there, fine. A complex numbers, why no, we know this in and out. Okay. This happens to be sum of residues inside. Residues inside. I'll do this pretty fast, Notice mod z is 3/2. That's a circle. Distance is same as the radius of 3/2. There are two poles here. There is a pole at 1, then there is a pole at 2. This is where the function blows up. Anything that is inside will leave it. So this happens to be residue of the function at 1. Whatever is inside leaves it. This by definition, remove that singularity, evaluate z equals 1. It happens to be 1 by 1 minus 2. I suppose this is minus 1. This is summation of residues. One of the poles is outside, doesn't leave any residue. So only this thing, sum of residues inside. I did it very fast. I think I can move on, right? No, if it's a bigger circle, even the second pole is inside, that will also give it. Remove that singularity, evaluate it at 2, calculating residue. So you can know we can do first order residue, second order residue, nth order residue, all of that we can do. This is a very typical, you're expected to know some complex algebra, but here, to see, the pole here is z is a by 3. Question is a contour, this, j by 3 is somewhere over here. So, which is a contour? It be in 2022. Don't know if that pool is inside or outside. Only if it's inside, it will leave a residue. So we cannot say. So outside of the contour, residue is 0. So no option is like given. 0 is not an option. Is that how explain this? Technically, this is imprecise for math. This is a poor question, but you have to evaluate this. Removing that singularity, that should be 2 pi j. And you need to evaluate this at is j by 3. Substitute it, I think, you'll find one of these options. I'm not doing it because, you're not defining a contour and really, is it like, because it's an MCQ, you're not defining a contour, that doesn't make sense. Does anyone know the key for this? This. Okay, I'm not really giving this any respect. Shoot it, you should get the answer, but I'm going to move on. A probability, again, almost every 2 years there is a question on this. A PDF is given. Probability function is given. There is an unknown coefficient. You always should do to be a probability. It has to be wherever the function is defined. If nothing is said, this is from here. Notice this is defined from minus infinity to infinity. Technically, so whatever is allowed, entire range, it has to be 1. But this integral is harder to do, so I'll do this towards the end. It is fairly simple. Notice there is an unknown coefficient. You have to find it. All right. To be a valid thing, f of x dx has to be 1 minus infinity to infinity. This 1 equals 2 times. I'm using some symmetry. If you think this is premature, I just substituted that function so far. Q and pi are constants. I pulled it out. E power minus x, you can write it as 1 by e power x. Some simple algebra that gave me this. In fact, this function is e power x and e power minus x. Okay. Even symmetry. This is an example where even on the odd points, actually neither is even. Two odd things kind of add up to give a even thing. This is somewhat harder to see, but f of x is this is this. Always the function is always positive. Even. Okay. And you have to deal with the summations of odd and all that very, very carefully. But soul's good. So because of that, I can do, this is 0 to infinity, twice of that function, because it's an even function. At this stage, the way to do this is this somewhat substitute y as e power x, then this integral is, this should give 2 cube. I get a dy by 1 plus y square. 0, I get this to be 1. If it's infinity, I get this to be infinity. Okay. There you have to recognize. Actually, yeah, you need not have done that too. This is, you could have done that, without recognizing it's even, you could have still done it. This happens to be 2q by pi tan inverse of y, elevated from 1 to infinity. At infinity, this is tan inverse of that as pi by 2, tan inverse of 1 is pi by 4. So that is 2q by pi into pi by 2 minus pi by 4. It is pi by 4. The value of q here, pi will get cancelled. Then you have pi by 2 here. Sorry, 1 by 2 here. So what is the value of solve for? Notice this whole thing happens to be 1. How much is this? Pi cancel. This is like, 2q by pi into pi by 4. That is q by 2. That equals 1. So q happens to be, at the stage I can answer this as 2. Notice, you technically needn't have done this, recognize it's even and done that. You could have done minus infinity to infinity. Then the limits would have been 0 to infinity. And when you substitute it here, this will be pi by 2 minus 0. So technically, you need not have done the recognize it's even, and you needn't have done this. But I kind of, did it and we kind of got it. Which kind of brings me We have to be careful about. Yeah, in fact, even be careful about even this. Or yeah, two evens should be even, but be careful about this. At the end of the day, this is all about internal. As far as things are consistent, it's fine, right? Okay, so probability, there is this question for sure. I mean, for sure, as in almost every 2 years there is a question. Find the coefficient, unknown coefficient, and okay. Then there are some miscellaneous questions as it showed up in aptitude. Then there is a base theorem question. I will simplify base theorem question, explain it, give you a very simple rule of thumb, and then we can kind of wind up. And there is one more question, right? Due to the current COVID pandemic condition, assume that positive or negative status of individuals are equally likely. There are 3 members in a family. If one of the members has tested COVID positive, the conditional probability that at least 2 members are COVID positive is fairly easy. This is enumerate the possibilities here. At least one of them. So this scenario is ruled out. So one of them is infected. So that no one is infected possibility is ruled out. I added the conditional element. At least two, right? These cases, there are at least two infected. So that is 4 out of total 7 cases. After ruling out the case not possible, and this happens to be 4 divided by 7, 0.57. Some enumeration based questions you can fairly easily do. Enumeration, that is, you can list them out, enumerate them out. Enumeratable. Enumeratable. Brought me to this base theorem question. Thing is a big question. How do I recognize it's a base theorem question? If something has happened, given something, if something has happened, when or ifs, I'm going to look for that. So if a drug is approved, something has happened, that statement is given. Probability of something else tells me I'm looking at a base theorem question. Or given something has happened. Find probability of something else. That is telling me it's an inference problem. That's a base theorem question. What do I do? The first one, call it A, the approve. The other thing, call it B, drug causes side effects. Label them. Or so simple. Thing has happened. I'm going to call that A. The probability that we need, I'm going to call that B. You can call it the other way around, no issues. I need here as probability of, I need as probability of B given A has happened. This is just the other way around. A given B, probability of B. Right? Thing repeats. Give it slightly better contrast. Numerator repeated. For very easy to write. Completed with the complement of this, what you're looking for. That is complement of what I am looking for will be, because I'm looking for, this is A given B, but complement. Question language, drug doesn't cause side effect. This is what we, just in case, notice if you put the complement to A and all that, there should be a complement. Let me put it at A. The BB and all will telling you it's a memory aid. To be complement of B. For so good. Now our man, if we write down what all these probabilities are, we are done. Probability of A given B. So let's write down easy one. Probability of, then probability of B complement. And then we need two more things. Probability of A given B. And then conditional probability of A given B bar. Probability of B. Probability that drug causes side effects. Manufacturer believes that be a percent chance that will approve a new drug plans to distribute if the results of the current testing your drug causes no side effects. The 0 point that a drug will be approved even if the test shows side effects. If the working for a drug believes that there is a probability test will show side effect. Yeah. Physician working. There's some sort of prior knowledge. He thinks test will show side effect. Probability that it has side effects. The probability is given to be, that means the probability that it doesn't cause side effects, that is 0.8. Negation of that. This is negation of B. This is 0.8. Probability of A given B. Drug is approved given that it causes side effects. There's a small possibility for that. Even if it shows side effects, a drug can be approved. So this number is given B bar. Doesn't cause side effects, gets approved. Just this scenario. We know all the numbers involved. Can we quickly calculate what this ratio is? And if you want me to retain the color consistency, this is easier to see in that equation, I suppose. This is probability of B, probability of B bar, probability of yeah. Calculate what this is. That brings us to the end of scheduled time. Yeah, we'll wrap this up and I the answer happens to be 0.116. A called one A, another one B. We want as probability of B given A, that is probability of A given B into probability of B. Write down the same thing and then write it in the complementary world. That is probability of A given B bar into probability of B bar. Real difficult thing is finding these values from the question. That reading comprehension part is a difficult thing, and that comes with practice. The issue is not with Bayes' theorem. The issue is not with probability. The issue is rather with reading RNC, reading and comprehension, right? If you practice, you can kind of do a couple of Bayes' theorem problems. You can easily get it. So last question, there can be distribution based questions. For example, for a binomial random variable, the expectation of X is this, variance of X is this. Which one of the following cannot be true? For a binomial distribution, quickly E of X, you are expected to recall N times P. You recall your Reifus variance of X. This is N times P multiplied by a 1 minus P, a fraction. P. So you can quickly see the expectation should be greater than variance of X. Why do we say that? Because I am multiplying expectation by a fraction. 1 minus P is probability. 1 minus P is a fraction between 0 and 1. So the number gets smaller. Okay. For that reason, variance is small. Variance is small. Variance cannot be big. Variance is small. Cannot be big thing. For this, what do you need to know? You need to know this table over here. Hey, what is the PD, probability distribution function? What is the mean variance for binomial, geometric, normal, uniform, exponential? This much you need to know. Notice exponential distribution. We have used this in, attenuation, X-ray attenuation. This is, say, the mean free path or the mean life. You can get that from the attenuation coefficient or, radioactive decay constant, right? Is on distribution. Again, you can find the mean number of variables, mean life, something like that. Mean count from, if you know this mean and variances. So it's useful in core subjects. Also, if you know this table, that's fairly, very, very useful in problems like this. What is left is there was a Laplace transform question. Okay, there is numerical methods, and there's this. Yeah, this is also a question based on Laplace transform. A differential equation, signals and systems that I mentioned. Numericals method. So far, there is this. I actually have put up a video on that. But anyways, I'll come back and discuss. But this is somewhat a hard thing that if you use Laplace transform, you can solve this very fast. I can show that to you. And rest of the questions are all measurements and statistics. The mean and median of this data. Can you fit a regression line? What are the regression coefficients? Right? And we can discuss that along with the measurement based questions. Hey, what is a measurement uncertainty? What is this combined, standard deviation, things like that. Let's stop here. That done with this. %50 marks from 10% of the concept? I would say yes. But you need to be brave. You should put your aversion towards mathematics, that you should learn to control your heart rate, let it not rise. You should be brave. Approach the question. You should ask, is it a basic definition? Is it verifiable? Can I take one or two? Some of this you have to do some, at the end of the day, you're all engineers, right? You should be able to do some basic, simple, derivatives, finding roots and all that. That step is involved. You do that. Can retain your edge. Let go of it. You can retain it. You cannot get an edge. You can retain. That is, you can retain your. That's fairly easy, and that's what I wanted to. Some of the harder things, some of the measurement things, and all that, I'll do it. But whatever definition, whatever common sense. Actually, I use a lot of common sense, but they rely on definitions and properties. You are expected to know that. Be very clear on that. Gradient is something. What is a gradient? Be clear on that. What is eigenvalue? What is this characteristic equation? What is Cayley-Hamilton theorem? Be very clear on that, including what is an adjoint, what is a cofactor matrix, and all of that. So be very careful with definitions. Be brave to apply definitions. See if you can answer a question. And if you find mathematics very hard, try this at the last or the last 30 minutes or something of the exam, not at the initial. So that's my suggestion. If there aren't any other questions, let's stop here. And if you need 20% of our concepts where 80% of question shows up, including many of the things that, I didn't really get time to discuss today outside of the PYQs, you can go take a look at this video.